Thanks again for the opportunity, Ron. This is awesome. And, good morning, good afternoon, or good evening, wherever you guys are. Hopefully you guys had a good session so far. So I'm going to talk about networking in Azure today. So basically, this is not a deep dive session on networking architecture. This is going to be a very high level. Obviously, I'll also talk about why we need to talk about network architecture, especially when you are a developer, what that means when you are a developer knowing about a networking architecture as well. So my name is Jay Kumar. I'm a cloud solution architect with Microsoft. My job is to work with my customers to provide them, solutions, cloud-based architecture, help them in adoption and cloud technologies and things like that. So I act as a trusted advisor for my customers and then help them in the journey for digital transformation. So alluding to the point why we, sorry, not moving this. Okay, so I just wanted to give a quick intro on why we are talking about network for a lot of the developers. So basically, if you think back around 10 years, most of these skills that people used to have are commoditized. They used to have a siloed type approach. Things were like mostly around technologies or a platform or a language, things like that. And then with the advent of cloud and agile technologies, DevOps and stuff like that, we are making it much faster to the deployment world or like the production environment. And so we just need to have more strategic skills and to make sure that we all utilize the features, the feature set and capabilities of cloud, and to develop based on that, we need to have some sort of background information of all these things. So again, in my background, I came as a developer in the beginning, and then I just became a system integrator, then application and platform manager, things like that, and finally ended up as a CSA or cloud solution architect. So my role was not really networking, but I think it actually forced me, because I'm a cloud app and infra architect. It is imperative that I also know a lot of stuff around networking. So this session is mostly around developers, how they can get most out of the networking side. So obviously, you guys may all know about this foundational picture here. So if you look closely into any Azure region, underneath the cover, everything is a data center. Like we have multiple data centers in each region, and you have physical assets or infrastructure sitting in any region or in any data center. And on top of that, we actually provide infrastructure services, or IaaS, infrastructure as a service. And the key components of that is compute, storage, and networking. So we provide servers to the customers, and a server is pretty much a combination of compute capacity, that is a CPU, and then the storage, which is the disks, and then the networking that ties all these things together. And it is carved out of this physical infrastructure that is sitting in the data center. That is called the virtualization technology. And on top of that, we provide the platform services. Platform services are managed services that customers can utilize. They don't have to really care about how to upkeep or operationalize or like manage their physical or the virtual servers. And then they can actually pretty much focus on the application and then the deployment of the application and the actual functionality of the application. That's why we use PaaS services, and it is scalable, and you don't have to really care about adding scalability at the back end. And scaffolding all these things, we have two pillars here. One is called the security and management. You all know about it. The hybrid operations. When you are operating in the cloud, we need tools to manage all these resources. So we have operations tools. One of the design philosophies of Microsoft is that we wanted to have all our tools very much hybrid in nature. This means that we never thought that people are going to ditch all that they have in their on-premises and go directly into cloud. So we wanted to have all the tools playing well with their on-premises or another cloud or Microsoft Azure. So all the tools provide a single pane of glass that actually you can look at all these things, especially security, operations, DevOps, and all kinds of things like that. So with that, I'll just move on to the next slide. So obviously, this is the hybrid cloud architecture. You have an on-premises cloud or a non-cloud type architecture. And when I say cloud, it is all about ease of deployment and a framework that you have made it like a cloud in your on-premises. And then on the Azure side, you have the hybrid, the Azure data center and the regions, and you connect between these two. And we will talk about some of those connectivity options in a couple of slides. Let's talk about the global infrastructure and footprint of Azure. So we have around 60 plus regions all over the world, and around 2 million miles of fiber that is laid out connecting all these regions. So this is one of the biggest or the most the highest number of cables that we have put comparing to other vendors. So other cloud providers. So this also provides high security and connectivity and things like that, because we don't lease out any of these, we manage them. And there are millions of servers sitting in all these data centers. So I just wanted to show that this is a massive infrastructure, and then you will be able to deploy applications globally using Microsoft Azure. So now looking at the big picture of network, what does a network infrastructure mean in cloud? So if you are deploying something in Azure or for any cloud for that matter, you have a public endpoint. Usually this is, let's say this is a external customer that is connecting to your application, or it could be an internal customer coming from your on-premises environment, or it could be an external customer. For the external customers, they may be getting a public endpoint, which is a URL that they will be hitting into. So we need to have an endpoint that actually provides a public connectivity. And then on the back end, we are going to have a secure connectivity to the back end, where the engineers can manage your application or deploy your application and look at it, all kinds of things like that. Or even there is a backend component that is sitting in on-premises that it has to interact. So all those connections go into the backend. So for the users, it's always through the internet. And for the backend, we have multiple choices. We have something called ExpressRoute, which is a private dedicated line that you can draw. Or you could use a VPN tunnel, which is an encrypted tunnel that goes through internet. A tunnel means it's not a dedicated connection, but it seems like a logical connection, which is encrypted. And so you like tunnel through the internet, which is a private connection, seems like a private connection for you, but it is encrypted. And then we call something called virtual network. Virtual network is a definition. By definition, it is bringing your own network into Azure. So let's say you have an on-premises environment where you have a bunch of servers, and they have a designated set of IP addresses, and you are extending your footprint into cloud. So you want to carve out some space in Azure, which is, even though it is a multi-tenant environment, you want to have an area in Azure that actually looks like an extension of what you have in your on-premises. That is called the virtual network. So it seems like a private IP space, but it is the technology that we say it is called virtual network. So those are the definitions. Now let's look at the differences between a classic network architecture and a hyperscale network architecture, right? So in a classic architecture, like in your on-premises environment, you will have all these hardware assets, like the devices that connect them, and switches, routers, all sorts of physical assets that actually build your network. When you move on to cloud or a high-performing modern or software-defined networking, there is a bunch of physical assets that are sitting at the physical layer, but everything on the top of that, which is abstracted out and given to you, is a software-defined networking. So on the classic side, you have mostly the L2 or the level 2 type communications, which is like addressing your MAC addresses, like directly addressing the devices per se. And then in the classic in the modern type networking scenario, we will have more like an L3 or layer 3 type networking, which is more IP based. So that is much more flexible, and you are not directly accessing a device by its MAC address, because we are actually moving around stuff. We are bringing stuff up and down and things like that. So this gives more flexibility and agility for our operations than high capacity type things. So this another way of looking at it is that we are separating out the different control plane, data plane, and the management plane or application plane into different strategic hardware, like which is not dedicated hardware, but we have commodity hardware. We can run these things in virtual machines and then plug these things together. That's another way of looking at it. So now look at the connectivity options that you have for on-premises to cloud. So let's different ways you can interact with the cloud with Azure. Let's say if you are a single user, like I'm having my private or like personal subscription, I am sitting at my home, I can directly use internet connectivity into Azure. That is most consumers, like one-off consumers or all kinds of people like that. So you can actually also have developers connecting to point-to-site connectivity. This is actually a way of connecting to Azure. Let's say you are hiring third-party people, and then you wanted to have them for a temporary basis. They are not using your on-premises assets. They wanted to go to Azure, but they have to be secure, and you give access to them to your subscription and all that. So you do a point-to-site connectivity, where this is almost like a VPN connection, but it is just from that machine to the Azure cloud or the virtual network that you guys are working with. The third scenario is called a site-to-site VPN connectivity. So this is basically you are connecting your on-premises site into Azure using a site-to-site VPN. And then by virtue of you coming into your on-premises environment, you can go through that VPN tunnel and then go into Azure. So basically, once you are in your on-premises, by physically being there or by connecting to your on-premises environment by a VPN sitting at home, you can actually ride through the connection from the on-premises to Azure using a site-to-site VPN. That's the third part. And the last one is an ExpressRoute connectivity. It's a private dedicated line that you can connect from on-premises to Azure. This is usually for big enterprises and that needs much more bandwidth and power like that. So now there is, I will not go too far into all that, but this is the concept. You can actually have multiple VPN connections, one from site 4 and other from site 5 here, and then you can actually interconnect all these things between multiple regions and all that. And there is a network terminology called BGP or Border Gateway Protocol that actually automatically finds the routing and then does all these kind of things for you. And this is not transitive. Like you can, there is another thing you can say, it's called something called peering. So you can actually go from one place to the other. There is no direct connection from VNet 3 to the on-premises server on site 4, but you can ride through the VNet 2 and go into all that. So this is a way of connection for VPN. Now let's talk about ExpressRoute. ExpressRoute is a much more powerful and a private connection, a dedicated line that you can use. Usually we use providers to do that. So the way it works is you have a WAN connection, which is like a wide area network for your office, which could be connecting all your branch offices, or a provider that can connect you from your on-premises to a location where Microsoft comes into that location. So basically you interconnect from that location and then travel into Azure. So basically this is, you put your packets into the WAN and at some point it will get transferred over to Microsoft. That's the ExpressRoute connectivity. So the way ExpressRoute works is the customer network is connected to a partner edge location, and the Microsoft edge and the partner edge are interconnected. And based on the purchase and everything, the partner will do a logical connection setting there. They will interconnect you, and this ExpressRoute will allow you between the partner to Microsoft Edge. It will transition, and then you can go into a cloud space. There are two regions in the cloud that are showing. One is called the public or the PaaS services, which are in the public network segment, because PaaS services are multi-tenant services. And on the bottom of the page, you can see the VNet connection, where your IaaS servers and all that, like you have private IP addresses. So those two places, this will be transferred. The packets will be coming and transferred. So basically, this is the routing. All those kind of things will be taken care of by the ExpressRoute connectivity. There are a bunch of connection speeds. we can provide up to 10 gigabytes per second connection using ExpressRoute. Now, ExpressRoute can be implemented in a couple of different ways. The first one is called the Cloud Exchange Co-location connection. So basically what this means is your office or your on-premises data center is connecting to an exchange provider. There are exchange providers like Equinix and AT&T and all those people who actually and Microsoft connection comes into that exchange location. And once you have a connection to the exchange will interconnect you with Microsoft. The other one is called, if you are having a provider like a layer 3 connection, which is like AT&T or somebody. This is almost like connecting directly from your on-premises into Azure, just like drawing an Ethernet cable from your on-premises environment, plugging into Azure. But this has to be provided by a provider who can lay all the lines from on-premises into an edge location that Microsoft is providing. So they will connect you from directly into that. There is no exchange here. It's a direct connection. And the last one is called the MPLS WAN type connection. So let's say that you have a WAN provider, like you have a bunch of office locations that are interconnected, and your connections go around that ring, and the packets are floating around all that. If the WAN provider provides an endpoint and a switch over to Azure, you don't do anything. Basically, you will be addressing a location in Azure, and then because this WAN already knows where to route it, and it actually routes you into the Azure. So it's an any-to-any IP WAN type connection. So that's the third scenario that you can connect. There are different ways of connecting this. So and I just wanted to talk about the three different known ways of connecting ExpressRoute. So you can also coexist ExpressRoute and site-to-site VPN. So there is no problem with that. Usually ExpressRoute by itself is a redundant feature. It has two tunnels in that, basically for redundancy. But you can also add an extra redundancy by adding VPN and actually failover if anything happens to your ExpressRoute connection. So you can build that kind of a model as well. So now let me just talk about some other features of networking. So when you are deploying applications in Azure, you probably may need DNS sometimes. So basically you wanted to have let's say you are deploying an application that is accessible at different places in all over the globe. So you want to have a DNS lookup for that service, and then we provide DNS domains and DNS hosting in Azure, and it is backed up by 99.9% SLAs, and there is a global footprint of the DNS server. So basically, when you are looking up your services, you will be looking up at a DNS server that is closer to you. So that means there is less latency in looking up, and then you can actually have any cache, which means like they look up with the same address, with the same symbolic name. You can have multiple addresses behind that. That is based on the region where you are coming from. The second thing is called the traffic manager. The traffic manager is actually a global traffic manager scenario. Let's say you have an application that is available across the globe, and customers in Europe are actually routed to the application deployed in Europe, and then the customers in the US are routed to application in US. So let's say you have a high availability environment, like there are multiple installations of the application. So there is something running in US, and there is another set of app, the same set of app is running in Europe, and then you want to load balance between these two locations. So the traffic manager is a single endpoint that is available across the world, and then when the customer hits the traffic manager endpoint, it is a single URL. Let's say contoso.com, and that's a URL that you are hitting. Based on some rules, it can actually route you to the location that is closer to you, or there are different ways to route. There could be a round robin. The first customer goes to site 1, second customer goes to site 2, things like that. Or it could be a failover situation. The first one may be primary, the second one is actually secondary, and it will be there until the first one fails, almost like a DR like scenario. So we could also nest all these kind of relations. And the third tool that we have is called Azure Front Door. That is actually pretty much tailored for HTTPS type connections or HTTP connections. So if you have an application that you wanted to host globally, Traffic Manager is one choice of doing it. Azure Front Door is primarily used for more HTML type traffic. It's very much friendly with a layer 7 app, which is HTML. And it has the firewall, or the web application firewall, and the DDoS protection. So the only thing with the front door is that it cannot be used for traffic that is not HTML. Like, let's say if you have a different protocol, then Azure Front Door will not work for you. But Azure Front Door is primarily used for HTML type traffic. So I think I covered this thing. You have a DNS server. It has global footprints, and on all these places you have a presence for the DNS servers, and you can actually do fast query performance depending on wherever you are. So this is another slide that shows the differences between Traffic Manager and Front Door. So Front Door, like let's say the customer on the left side is coming in, and then you could use two choices. One is the Traffic Manager, the other one is Front Door. For HTTPS type connection, we always prefer Front Door. So that will get into, you can actually, at the second layer, you can actually have a gateway. I will talk about some of those things in a couple of slides. But then, it would be routed to a region or a zone, wherever that route goes. And the diagram on the bottom left corner also shows that there is a single URL for condoso.com that's hitting in, and then it could be deployed in different regions, and the customer can be taken to any of those regions depending on the rules we have set up. So now let's talk about load balancing. So once you hit into a region, this is all regional now. We are talking about within a region. So there are multiple levels of redundancy and load balancing and high availability we can build. So basically, when you are building a highly available, scalable, resilient application that is available all over the world, you think about ways to make it very resilient and highly available at the global layer, and then also at the data center level, right, or the region level. So when you are building an application and you have two VMs, let's say you're building an application with virtual machines and not a PaaS service. So a load balancer actually provides you an IP-based load balancing into two different servers. So you're deploying the application, the IP1 and IP2 servers, and the load balancer sits in the front of that. And the traffic or the user coming from internet, it could be coming from an Azure Front Door or a Traffic Manager as a secondary endpoint, or it could be a direct endpoint from internet. So this, we are talking about like the modular approach here, right? So when you come into the load balancer, you can also have different rules based on the load balancing rules. It could be going to IP1 or IP2 depending on how you select. There are three different scenarios here. The first one is public load balancing. You can actually expose the load balancing front end to the public IP, or it could be a private load balancing. You could use it internally. That scenario happens when you have the traffic coming from a global traffic manager, such as Front Door or a traffic manager, the global traffic manager, and then you come into a private IP addresses within Azure. So there is also outbound traffic. So basically, the traffic that is going out of your server going back to the customer is aware of where it is coming in. So it will be routed to the correct location that the customer is coming from. So these three scenarios are there as part of the load balancing feature that Azure has. So now one more complexity here is called the Azure Application Gateway. Azure Application Gateway is very much similar to the Front Door scenario. Like, this is for HTTP type traffic. So you could use Application Gateway for websites and things like that, not for like a standard TCP IP traffic. So if you're getting an HTTP type traffic, you could use App Gateway. The cool thing with App Gateway is that you can use it for use it to build a WAF, like web application firewalls and rules and things like that. It can inspect the incoming data on the layer 7 and then do some sort of security on top of it. So there are so it can actually inspect the cookie and all that, and basically that is only available at the HTTP level, right? If you are looking at the IP level, like internet packets, then you won't be able to look at the cookies and all that. That's the load balancer scenario that we talked about. So this also provides SSL termination. Like if you are using an HTTPS type connection, you could offload the certificate in the app gateway and then create and remove all that processing in the application gateway and then send the unencrypted traffic from app gateway into the virtual machines or the web application or whatever, whatever, if you are using a PaaS service, for example. So building all these things together, we have this scenario here. So, you have a region 1 and a region 2, and you have the customer coming from the internet and hitting an Azure front door, which could be a layer 7 HTTP load balancer or a traffic manager, which is a DNS type load balancer. It could be routed into 2 different regions, and on the regions you could front load it with a load balancer, which is like an IP based load balancer, and then underneath you can still build application gateway, which is like the WAF or like the application specific security and all that, and also load balancing, and then beneath that you can have the virtual machines. So this actually provides you the full coverage and then allows you to build an application that actually is globally available, resilient, and very much scalable. So you could actually go ahead, and if you guys are interested, there are a bunch of documentation around all these things, and there is also Azure reference architectures that is available across all these things, for people who are more interested to learn about all these kind of technologies. I think we talked about virtual network. Virtual network is when you are bringing your own network. So obviously, when you guys are like, the simplest example, when I'm having a home network, everything in my home is a private IP address, and then I have a router that is facing the internet, and the internet only knows that router as a single endpoint. That is a public IP endpoint, which is available to the WAN or the wide area network. And the same IP addresses will be reshared within my neighbor, and all people will be having the same type of IP range and all that. So similar to that, in your company, you will be using a private IP range. Another company will be using the same range, but we will not be talking to each other because they're all isolated. So you can bring your own IP addresses and extend your IP space into Azure. That is called the virtual network. And you can also bring your DNS or use Azure provided DNS for finding servers and all that. And these are all, you could also build network security groups. I will talk about that momentarily. And you could also do something called a user-defined routes. By default, Azure knows how to route all these things by system routing, but you could define something called UDR. That's primarily used for like channeling your traffic through certain endpoints and devices and things like that. You could do something called UDR as well. So that's another feature that we'll talk about. So network security groups. This is one of the foundational aspects of cloud. Obviously for your VNets, when we have deployments in VNets, and VNets are when you are deploying an application in VNets, we'll also divide them to subnets sometimes. And subnets are for pretty much like if you want to have an app tier, database tier, and a web tier and all that stuff, you will put them into different subnets and only allow certain types of traffic going back and forth and all that. So to do that, to control the traffic between these endpoints or servers or subnets or whatever, we do things called network security groups. Network security groups is nothing fancy. It is just a table actually. It's a table of 5. It's a 5-tuple table, which is or an access control list. So it has the source IP address, source port address, destination IP address, and destination port address as the inputs, and then a column that says allow or deny. So basically, it is just a table that tells me that okay, coming from the source port, source IP, going to this destination port, destination IP, whether I should be allowed or not. I can do set of rules and say deny everything else, things like that. Deny all is a rule. So basically you can do things like that. That's the network security group that you have in Azure. So this is a pretty, usually you don't have to build all these things. It will be available as part of the boundaries that Azure defined by default. But then if you want to alter that and you wanted to restrict traffic or add a traffic, then you will be able to manipulate network security groups. Now, there are things called virtual appliances. We talked about Fortinet and Checkpoint and all those people here, cool stuff here. So we could bring, they have appliances usually work on premises, but then they provide virtual appliances, technology, their own technology in Azure virtual machines, and that can be available in the marketplace. So we can buy and build similar solutions on top of, like, if you don't want to use Azure, or if you want to bring your own routing tools or like firewalls and things like that, then you use network virtual appliance or NVAs. So these you could build it like just like you build a virtual machine. And then this is where the UDR comes into picture usually, right? When you have a virtual appliance in front of your network, you wanted to route all the traffic going through that network instead of like directly, because you're just putting a resource there, and Azure doesn't know that all the traffic coming from on premises have to go through that network appliance. So then you will write a UDR or a user-defined network to route your traffic into that appliance and then go into the endpoints that are behind that. So there are first-party appliances and third-party appliances. There are several of these things you can find in Azure Marketplace. And then I think there is a bunch of them. We know about Checkpoint. We talked about Fortinet. I think it's here as well. So there are a lot of providers that give us these type of virtual appliances capabilities in Azure. Based on the need, there are a bunch of choices you have. So we talked about user-defined routes. So basically, this is exactly showing what I just mentioned. There is a system route, but then you want to have the system route is actually shown in red actually. So from the front subnet to the backend subnet, the traffic is already established using a system route. And if you are inserting a virtual appliance that is at the lower portion of the screen, you are actually forcing the traffic from the front end going to the virtual appliance and to the back end. That's where the UDR comes into picture. So you will have to break that system route and then give priority to the user-defined route, and then you set it up such that you will have a sniffing appliance or like a network packet inspection or whatever it is you wanted to do that, then you will do a VM appliance like that. So that's the use case here. So now let's also talk about some security aspects in cloud. From internet, when you are coming from internet all the way to cloud, overall the Azure as a whole is governed by DDoS protection. Whether it is not specific to a customer, the whole of Azure is governed by a DDoS watch, and then we have teams that are running all sorts of tools to find out if there is a denial of service type thing coming on Azure. That's actually irrespective whether you are customer A or customer B, that applies to everybody. And underneath you have the ACLs or the network security groups or the ACLs actually, I mean your access tiers, like you have the access controls, the role-based access controls, and then you will not be allowed to enter if you don't have an account. And then you have virtual network isolation. You have your own network that you bring into Azure. You have an isolation on that. Then you have network security groups that is, that I define, like you can restrict traffic based on network security groups. Then you can have virtual machine firewalls that you can also implement firewalls on top of that. There is an Azure firewall feature. And you can also opt in for DDoS protection on your own assets. Basically, that is the innermost DDoS protection layer, where we are watching at DDoS attacks directly onto your machines or your systems. So this is a layered protection approach that we have. So it is pretty much secure, and then we can actually supplement this by using other network security appliances and stuff like that that we already mentioned. So now, when we talk about a simple application, so I just wanted to cover, we talked about a lot of the networking. So from a developer perspective, how do we do all these things? Like, you have an application that you wanted to provide a global type service, and you have customers here in US, in Europe, in maybe in Asia. So you want to have a highly available application across the world. So in this scenario, I'm talking about two web services that are hosted on app services. That's in two Azure regions, region 1 and region 2. And then there is also technologies called Azure CDN. CDN is a content delivery network, which means that if you have static assets, you can actually provide it near to the customer, called points of presence or POPs. Basically, what it means is you have content that is like very much static, and it is not like a transactional or anything like that. So you want to load your page as fast as possible with images and text and everything. So you don't want to have your traffic going all the way into the Azure backend and then bringing it from a database and providing it to you. So you just host these at the front end. That is called the Azure CDN. There are technologies like that. And then there is a time to live in the CDN. So CDN will refresh itself. The cache will be refreshed after a certain time period, which is called time to live. After the time to live, it will just fetch the newer content and then keep updating that way. So that you could add CDN as part of your solution for faster performance. And then you have front door. Front door is also a globally available resource, right? So you have points of presence for front door. So when I am clicking on, let's say the URL I'm having is contoso.com, I'm hitting the contoso.com from sitting in Washington, DC, I'll be routed to the nearest contoso.com point of presence. And the guy who is sitting in Australia will be going into a contoso.com that is hosted nearer to them. And so that's much faster. And then once it is in the front door, it actually determines where it has to go. It could be in a region 1 or region 2, where you have the similar application, the same application deployed, and then you will have the whole transaction happening within that region. And you could also do database replication. In some cases, if you wanted to have active database failover, if one region goes down, then you could also do geo-replication of the database using, several methodologies like active failover groups and things like that. So there is a way to do that as well. So basically, this actually covers the end-to-end way of like a modern application. So what I'm trying to say here is that when you are deploying an app in Azure, we just wanted to compartmentalize and then think about ways to improve scalability, ways to improve performance and reliability and all that. And there are different well-known practices that you can use to slice and dice the application. And it's never going to work if you put a monolithic application and then put all those things in one place. So that's not going to work in the future. So what we do here is containerization and also doing serverless type approaches and then microservices and stuff like that, which we peel the application into certain layers, and then we design the application as a sum of the parts, and then we deploy them into different regions and provide high availability and resiliency for all those parts. So that way we will have a very, very robust and then minimal downtime. If something happens, it will be minimal to one component, and then you can have you can have solutions that can tell you that, okay, you can throttle it. For example, you can actually say denial of that particular service that is not available, not like making that the whole site is not available now, but I can say that, okay, some feature is not available. That's much better than the whole site being down. So that's the way of developing an application in cloud. And I think this actually pertains to my earlier point that we, as a developer, I should be also aware of all the technologies at the back end and how this is going to be deployed, because we are going to write DevOps as a practice as well, right? So when you are deploying, continuously deploying and managing applications in Azure, we need to make sure that the deployment happens to all the regions. Then we have the tools that then the developer who is writing deployment models and everything has to be aware of the deployment model as well, right? So it is just not the single application that is running within his or her desktop or laptop. So that's the scale of things that we do these days. All right, so I think I have, this is putting all these things together. So you have a customer that has internet connectivity coming, that the green and red boxes there, they could be also routed through a virtual appliance, Fortinet, for example. And then in the front end, you have filter them through firewalls and all that stuff. And then the middle tier, and then you have the infrastructure backend, which could be the database. And then, from on-premises to Azure, you could have ExpressRoute or VPN. And that also can be sniffed by using, virtual machines that can be hosted in the front end. And there are other accelerators like Riverbed and all that such technologies for accelerating traffic as well. But this is all the whole system, if you look at the big picture of the network. So that actually sort of concludes my session. And, we just talked about a couple of things here, how a cloud can be made enterprise ready, how the cloud can be used for global scale of your app, and how do we do complete solutions within cloud? What are the technologies that you need to know? How do you build them? And, just make sure that you have a robust and globally available app. And there are a bunch of strong partners that we talked about. And the technologies we talked about are user-defined routes, public IP addresses, and Azure DNS, all sorts of things like that. So that covers what I had to say. And hopefully that was helpful.